Welcome to qnawire.
Okay, we need to give the Lewis structure for HNC. Okay. So they're telling us the skeletal structure, right? We know that there's going to be an N in the middle, a bond to C, and a bond to H. The next thing I like to do is figure out how many electrons do we have to work with, right? Hydrogen is in group 1, gives us 1 electron. Nitrogen, which is in group 5, is going to give us 5 electrons. And carbon, sorry, this is getting ahead of myself. Nitrogen, which is atomic number 7, is going to bring Nitrogen, which is in group 5, is going to give us 5 valence electrons. And carbon, which is in group 4, is going to give us 4 valence electrons. Okay, so we've got a total of 10 electrons to work with. We've used 4 of them, right? Each bond contains 2. We also know that hydrogen can only ever have a single bond and won't have any lone pairs. So the remainder of the electrons will either have to be bonds between nitrogen and carbon or lone pairs on nitrogen and or carbon, right? Something else we may know is that carbon, being in group 4, always wants to have 4 bonds and no lone pairs. That's pretty much the only way carbon can be satisfied without a formal charge. Remember, because formal charge is calculated as group number minus the number of bonds minus the number of electrons in lone pairs. Okay. Well, to meet a full octet, right, carbon and any other element that obeys the octet rule wants to see 8 electrons. Okay, so in terms of bonds, we could do that by giving it 4 bonds and no lone pairs, or 3 bonds and 2 electrons in lone pairs, or 2 bonds and 4 electrons in lone pairs, or 1 bond and 6 electrons in lone pairs, or no bonds and 8 electrons in lone pairs. But the formal charge that we would get for each of these possibilities following this formula, knowing that carbon is in group 4, is going to be 0, -1, -2, -3, or -4. So ideally, we're going to want to give carbon 4 bonds if possible. Followed then by giving it 3 bonds would be the next best in terms of minimizing formal charge. We'll consider if we want it to have 4 bonds, it's going to need a quadruple bond here. That's not even possible. And 2, nitrogen's already got a bond to hydrogen on this side. So that's not going to help us, right? So we want to give carbon 3 bonds. That's probably the best we can do, right? And that's usually where I start. I usually look at carbons and try to satisfy all of them, giving them as many bonds as possible, up to 4, but relying on 3 if necessary. Okay. So at this point, we've used 8 electrons, which means we have 2 left. Now, nitrogen has a full octet. Carbon does not, right? So this lone pair is probably going to end up on carbon. Okay, now we already know the formal charge on carbon, right? We have 3 bonds, 2 electrons in lone pairs, that's -1. What about nitrogen? Is there a formal charge here? Well, it's not immediately obvious, but we can calculate it, right? Nitrogen's in group 5. Here it's got 4 bonds and 0 electrons in lone pairs equals +1. This is the best we can do. We know this because any other arrangement would only increase the formal charge on nitrogen or be impossible because we can't give carbon 4 bonds without increasing the number of bonds to nitrogen, which is impossible because it has a bond to hydrogen. These formal charges are minimized because we built them from the ground up to be minimized.